expedition where we are mapping near Johnston Atoll, one of the most remote atolls on the planet. Mapping data that our team is currently collecting is contributing to the Seabed 2030 project, which is a goal to map the entire seafloor by the end of the decade. Our maps will also be informing our next ROV cruise in just a few weeks. Fun fact, scientists have better maps of Mars than they do of our own planet. That's why we're here to change that. But for now, today we're celebrating World Ocean Day. First designated by the United Nations in 1992, every year June 8th is marked as a day to celebrate the ocean and the work done by oceanic explorers like our own Corps of Exploration. One such explorer is Adrian Currington, who is joining us from the control van right behind me. Adrian, you're well acquainted with the control van and all of the many things that go on in there. Tell our viewers a bit about it.
Hello, I'm Adrian Currington. On board the Nautilus, I am a Science Communication Fellow, and on shore, I'm an illustrator and cartographer. And as Maddie said, we are hanging out in the control van, where we usually gather to do our remote-operated vehicle dives. So that's when we put our ROVs in the water and explore what's down below. But today we're gathered to celebrate World Oceans Day, chat with you, do some live Q&A, and share a bit about what we're doing in this area on this expedition. But to see a little bit more of the vessel, we've got Yashira on the aft deck. Yashira, you want to show us what's going on out there?
Yeah, of course. Hello, everyone. I'm Yashira Cruz, a Science Communication Fellow aboard EV Nautilus and a graduate student at the University of Central Florida. I'm coming to you from the aft deck, which is our team's platform for holding and deploying our remotely operated vehicles, such as ROV Atlanta right behind me. Now, this particular expedition has kept our ROVs on deck, but our team has been working really hard to unveil pretty exciting and fascinating structures below the waves and down in our seafloor. And this is some pretty exciting work because about 80% of the ocean is yet to be mapped. We're so excited to be here with you. Please start submitting your questions for our team. And back to you in the control van, Maddie.
Yeah, awesome. Thanks, Yashira. It is so good to see you out there. It looks sunny and warm.
So nice.
I'm definitely heading out there after this little interaction here. But as you all can see at home, we have a full house up here in our control van. Don't forget, just as Yashira mentioned, to send us your questions during this very special World Ocean Day event. You can do that at nautiluslive.org. Let's go ahead and meet our team, though, starting with Dave. Dave, how's it going back there?
Oh, great. I'm Dave. I'm the video lead and pushing these buttons here. See if I can get us up here. There we are.
There you are.
Hi, I'm Dave, video lead and running this show currently. Over to you, Elijah.
Hi, everybody out there. My name's Elijah. I'm on land. I am an undergraduate med student at Tuskegee University, but this summer I managed to get a fantastic intern opportunity to come aboard EV Nautilus for a couple of weeks. Over to you.
Hi everyone, I'm Ariana Uwabi. On shore, I am a NOAA Center for Coastal Marine Ecosystems graduate scholar, and here at Florida A&M University. And here I'm serving as a seafloor mapping intern.
Hi everyone, I'm Haley. Here on the ship, I am a mapping watchstander, and on land, I work for Columbia University's Lamont Doherty Earth Observatory, working on a bunch of different projects, including the aforementioned Nippon Foundation JEBCO Seabed 2030 project.
Hi everyone, I'm Chris Krasnowski. I'm a postdoctoral researcher at the University of Rhode Island. I'm out here to improve Hercules's mapping system for the next cruise.
Hello, this is Albert. I'm here as a mapper, like Haley. I'm one of the watch leads as well. And on my mainline work, I work at Aqua Robotics as a software engineer developing software for the AUVs that the company commercializes.
So, hello everyone. I am Paul Alejandro Kennedy. I am the Chief Officer of Exploration Vessel Nautilus. I am in charge of Navigational Watch. according with the data lab requirement, and also I'm in charge of the safety and the security of the vessel.
Awesome. Thanks, everyone. As you all can see at home, it takes so many different roles to fulfill the mission of EV Nautilus and the work that we do. And some of those roles are including a scientist ashore, which we often incorporate into our expeditions. One such scientist today joining us is Taylor Ann Smith. Taylor Ann, you've also sailed aboard Nautilus before.
Hello, hi. Yes, I have. I've actually sailed with Nautilus for a couple of years. I started in 2019 as an intern, and currently I am the science manager and will be tuning in from home here in Los Angeles. But I will be out on the ship next week. Yeah, in a few weeks, I'll be out in Honolulu for the next cruise for the Johnson Atoll. I'll be out there. We're going to be focusing on characterizing the area around the Johnson Atoll and making sure that we're taking note of all the corals and sponges that we're discovering out there. So I'm looking forward to it.
Awesome. And Aaron as well, who is our current expedition leader that we're working with to map the seafloor. Aaron, can you tell us a little bit about yourself and then, of course, what this expedition is all about?
Hi, Maddie. Sure. Aaron Heffron, co-expedition leader on this expedition. I've been working with the Nautilus for about 6 or 7 years, primarily as a mapper myself. That's my training and background, but also as a navigator. What we're doing right now, so yeah, we're in the middle of Johnson Atoll unit of the Pacific Remote Islands Marine National Monument. We've been out, this is about day 15 of our cruise, doing all of this great mapping. And so far we've mapped 26,000 square kilometers, which is about a little over 16,000 square miles. So really making a dent in this area, which really has not been mapped. Just as Maddie's been saying, most of the seafloor has not been mapped, and about 80% of this this monument has not been mapped, which is striking because this monument is part of the US EEZ. So this is our own kind of ocean property that we haven't even mapped yet. So I'm really excited that we're getting to contribute to the maps and prepare for the next ROV cruise. Back to you, Maddie. Thanks.
Awesome. Thank you for that very succinct overview. And then, of course, for those of you who might just be joining us, this is a special World Ocean Day event. We're really excited to be sharing with you all the current expedition, which is mapping near Johnston Atoll, one of the most remote atolls on the planet. And everything that we're doing today is work, and for the last couple of weeks, and for the next week, of course, is informing our next cruise, NA-141, which will be conducting ROV dives in the Johnston Atoll unit. So Taylor Ann is joining us from shore at her home in Los Angeles, and she's going to tell us a little bit more about what that expedition is, but I want to toss it back to our science communication fellows, Adrian and Yashira, who are in the control van right behind me. Are you guys having any questions? What do folks want to know about our current expedition?
So many things, but let's start with, we're talking a lot about mapping. So what is mapping as in a profession, and how does one become a mapper? How many degrees do you need in mapping? Can you study it at school?
That is a great question.
I'll grab that one. Haley here again. So you don't need a degree in mapping to be a seafloor mapper. The interns that we have aboard today actually do not have backgrounds in seafloor mapping at all. My background is in marine biology, geology, and I also have a minor in Japanese studies for fun. So while I did have a science background, it was absolutely not necessary for us to come aboard the ship. Elijah, I think you have a pretty interesting background that absolutely has nothing to do with
I think everybody on the ship has an interesting story of how they managed to get here. Mine probably being the most drastic, as I am a med student. I had no inclination of anything regarding researching the ocean as it is. So I was offered. I joined a club at Tuskegee. Based on that, was the entire point of the club is to get people to at least look at blue economy jobs, like any type of job that can lead you back to the ocean. And the one I'm working on here is obviously to come aboard the EV Nautilus and do a little bit of mapping. So this is my first time doing anything like it, and it has been a fantastic experience so far.
Yeah, and I know Ariana, you have a background in science, but not necessarily mapping, right?
Correct. I'm actually an environmental science major at Florida A&M University, and I mainly study microbes in Lake Erie. So I've never been a seafloor mapping intern. I've never done anything with seafloor mapping. I just found this opportunity and thought it was a great way to learn about it, since 80% of our ocean is unexplored. So I just thought it was an interesting thing to come aboard and learn more about mapping.
Awesome. How about you, Albert?
Oh, sorry. I have an engineering background. I did my PhD in underwater robotics, so I did study a bit of the technology behind all these sensors that we use. But as Haley and the intern said, it's not required for getting out here and working as a mapper on the Nautilus.
Yep. And we did have a question about how undergraduate students can be involved. As you heard, we have interns, so all you need is to be over 18 and to have a passport and to have an interest in trying something new, and you can apply for our program.
Yeah, and I just wanted to add, our applications for the internships are actually opening in August. So go to nautiluslive.org and you can look at our internships in science, engineering, and mapping.
And Maddie, did you have something else to bring up before I get into some of these questions?
Yeah, well, I wanted to pop it over to Aaron really quickly and just get a little bit of insight about the other many backgrounds that people can come on ship and what leads to ocean exploration.
Hey, Maddie, thanks. Yeah, that was a great hearing from everyone in the control van, and totally agree. You don't have to have a background in mapping to get out here. And we really love the broad, diverse groups of people we can bring from all different backgrounds to see what mapping's about. But the internship is just one step, right? And we are so happy to have people come out. But then as you get into this as a profession, you do need to pick up experience and background. So as Albert said, he has an engineering background. A lot of people have that. Myself, I have a mapping background, where I actually did get a mapping degree. And it helps you learn things that you can get a little more in depth into the acoustics. You can get that through education or experience. I know people who've done both and are world-class mappers in both ways. But like you said, we do have all kinds of people from all backgrounds out here and so many different support roles that even on a mapping operation like this, we have people who are not mappers at all that are coming out to support in other ways, like Dave on video and like our science communication fellows, all making up this really kind of great team to get this job done. Thank you.
That's right. Yeah, it takes all different backgrounds, including our crew, right? Somebody has to make sure that the science team is fed and that our ship is operating safely, and that's where Paul comes in. Paul is a member of our crew, and he's joining us in the control van. And Paul, what brought you to EV Nautilus? How did you get here?
I applied by internet, and I joined the ship in the middle of refit a few years ago. So I could tell to everybody that I built her new one, and I love to work here because I think it's really important for navigation matters. Also, it's not only science. So for to create roads, to go around the world, it's necessary to know what is down below in the ocean, and also I discovered many species when I saw the diving operation from the bridge, and I really excited of that because I love the ocean, and I also an environmental control technician, so I think it's a really important thing and a really important show that the Nautilus is doing.
I love that you said you love the ocean, because I think that's the one thing that ties everyone on the ship together and how you get out on a ship like EV Nautilus, and that is a love for the ocean. And and just sort of that desire to explore more. For those of you who are just joining us, this is a special World Ocean Day event. We're here to celebrate all things ocean because, as Paul said, we all have a shared love of the ocean. If you have questions, you can go ahead and submit those through our website at nautiluslive.org. We are currently operating a mapping expedition in the Johnston Atoll unit, which is in the remote Central Pacific Ocean. It's one of the most remote atolls in the world, so it's been such a treat to be out here. And since this is a mapping expedition, I'm going to show you all just a quick visual of what that mapping looks like. So this is EV Nautilus, of course, and this is our bathymetry multi-beam sonar data. So it's like a ping, right, Haley? Can you talk a little bit more about what that data is and sort of how it works to reveal the seafloor?
Yeah, so I'm going to try to do this justice. So you'll often probably tune in to one of our live cams and you'll see the live collection of the seafloor data. So when you're looking at that image, you'll see one giant top image, and that's the live acquisition of that data. That data is collected by a giant swath of sound, a cone of sound sent to the seafloor, and based on the returns of that, we can determine what the seafloor looks like. When you're looking at that particular window, you could also see below, you'll see the water column data because there's a lot of unique information that can be found in that water column. And then you'll also see the backscatter to the far left, and that's the intensity or the hardness of the seafloor returns in that sound. So yeah, I mean, just like when you're looking at a map of like mountains, when you see those high red intensities, that means it's a little bit, or not intensities, the high reds in the bathymetry, you'll see that it means that's a shallower area, although not very shallow here. Right now we're at 4,200 meters at our shallowest and 6,400 at our deepest. But yeah, so we use sound just like bats use echolocation. We use it to locate the seafloor.
I heard a great sort of metaphor, and that is it's sort of like we have a blanket over a chair, right? And that's sort of what the satellite data that we use initially. Yes. It's like Google Earth, and so we can see the shape of the chair underneath a blanket. We know that there is something there, but we don't know exactly what that shape is and what that chair looks like specifically. So once we remove that blanket, right, once we collect that bathymetry data, we can really see in greater detail what it is we're looking at. And what we're looking at here is informing our next expedition, which Taylor Ann Smith out of Los Angeles is joining us. We're going to see you in just a week. Taylor Ann, a huge component of what we do aboard Nautilus are those ROV dives, and they really pull up things like this, right? This video that we're seeing. Taylor Ann, can you tell us a little bit more about this next expedition and then, of course, ROV research in general?
Sure, I would love to. So this expedition that we're currently on is actually going to be helping out a lot because mapping the seafloor will help us know what areas that we're interested in looking at to characterize what creatures are living there and the diversity of life that we're seeing there. So on the cruise that I'll be taking part in a few weeks, we'll be characterizing the Johnston Atoll, the area, seeing what types of deep sea sponges we're finding, corals, also paying attention to the geology and structure of that environment. It's one of the most remote places and atolls in the world, so it'll be really interesting to see what we're finding based off of the mapping data that we're collecting and other data that we've collected in the past. So yeah, it'll be amazing. Sometimes we find new species, so you really got to stay tuned and watch our live streams when we're out there diving.
Absolutely, and this video that you all are seeing is sort of what it looks like from the ship today, right? As Taylor Ann said, it's one of the most remote regions in the world, and you can't see land anywhere. So it's been really fun to get all of our sea legs ready and, kind of learn together what that feels like. And again, for those of you just joining us, it is World Ocean Day. We're celebrating through this special Q&A. So if you're joining us, please feel free to submit your questions at nautiluslive.org. Adrian and Yashira in the control van right behind me are fielding those questions. What are you guys hearing? What do folks want to know?
Well, they were really interested in all of our career chat. Someone wants to be Aaron when they grow up. And speaking of Aaron, Could you describe to us what that chirp sound is that we hear when you're speaking to us, Aaron?
Oh my gosh, can you hear it?
Yes,
yeah, so that's, I don't know if I hear it anymore. That is our sub-bottom profiler. So what you see when you're looking at the screens is mostly our multibeam sonar. That pings at 30 kilohertz or around about that, and we cannot hear it as humans. But we can hear our sub-bottom profiler. It's another type of echo sounder, and that pings at 3.5 and 15 kilohertz. And we can, as humans, hear those lower frequencies. So all throughout the ship, no matter where you are, including on the monkey deck, which is the top part of the ship, you can hear the ping from that sonar when it goes out. And so that's actually what's happening, just the acoustic pulse going out and coming back. And the lower frequencies with that one allow us to penetrate the seafloor and see the layers that are beneath, and that's why we call it a sub-bottom. So hopefully that helps. And then as far as how to do this when you grow up, a lot of experience. I do have a degree in ocean mapping, but I also spent 10 years working in the industry. I worked for the software company that does the software that you might see us demonstrating, QPS, Fledermaus, and Chimera. It's our processing software. And I also did a lot of work going to train people, different institutions, learning about their workflow, and then went back to school to learn about the acoustics and things. I had a background in geology and GIS, which set me up really well to start learning about it, but then to really understand how this mapping works, I had to get into the acoustic side. So that's my story. Back to you guys.
Yeah, thank you. Actually, there was a question about how much we actually end up mapping during an expedition season. That's a pretty tricky question. I don't know if anyone can really answer that, but about how much can we get mapped in one expedition?
I don't know.
That is a really challenging question.
I know how much we've mapped so far, right? Square kilometers or so.
Right. On this particular trip, how long have we been out here, guys?
2 weeks.
2 weeks. It is day 15, I believe I wrote down.
Wow, it's like sometimes at some point you kind of lose track.
Yeah, regarding this, like sometimes it's easier to see, like when we put the bathymetries in the middle of the ocean, it's difficult to see the areas that we've mapped so far. But like yesterday night, I was doing an interaction from a school at nearby where I live. I live in near Barcelona, in Spain. So I moved all the bathymetry that we did so far during this cruise over to Europe to realize that we've done something going from like mid-Italy to Madrid and almost back to Barcelona again, and mapped like a fair entire amount of what's in between that region. And like when you put the bathymetry over some ground that it's easier to recognize than just blue water in Google Maps, it's easier to see that we've done a long way. Although when you zoom out and you see the entire picture of the ocean or of the world, it's like still a tiny spot.
And Haley, do we have a fresh number on how much of the world's oceans that we've collectively mapped?
We have an unofficial number of between 20 and 23%. The official number will be released later in June. Yeah, so the project I mentioned and Maddie mentioned earlier, the Nippon Foundation JEBCO Seabed 2030 project, which seeks to compile all available bathymetric data and make it freely available to the public in a JEBCO ocean map. Gets released, its 2022 release happens later this month. So we'll get a better update, but yeah, 23% roughly is what we're looking at right now. So as we know, 70% of the globe is water, and only 20% of that is actually mapped. So at any sort of reasonably high resolution being like 100 meters.
Amazing. So
really
that's just in 2 weeks we've mapped that.
I could add
Yeah.
that we sail about a day. So each 24 hours, the ship is sailing about 300 miles, and so we are mapping 300 miles per day.
And you're one of the people that's in charge of keeping us on course, right?
Yes, I am.
I've seen him do his work. It's amazing.
Yeah, and in addition...
Hey, just pop it in. This is sorry, this is Aaron. I do have Lindsay, our mapping coordinator, who's not on this event, unfortunately, is now working to get us the stats. So we'll update when those numbers come in for what we do in an expedition season.
Awesome. Thank you.
Hey, thank you, Aaron.
Yeah, yesterday or day before, Lindsay and I were chatting about our total stats, and I think we figured out that we've mapped more data of New Hampshire at this point in time. So we've done a lot of work in the last 2 weeks, for sure. And then, of course, in addition to mapping, OET, which stands for Ocean Exploration Trust, and the Nautilus Exploration Program centers around exploring the ocean in many fields, right? We have communicators on board. We also have experts in geology, biology, maritime history, archaeology, chemistry, as Adrian likes to say, all of the ologies that, of course, push the boundaries of education, outreach, and technological innovation. And some of that technological innovation, of course, is our ROVs, which we use to get eyes on the seafloor. And Chris, you mentioned that you are working on Hercules. Can you tell us a little bit more about the ROVs and sort of what goes into your experience in working with them, and what are some of our goals for this season?
So yeah, well, as you know, the ship has been doing a lot of mapping over this year and over the past few years, and we want to be able to do a little bit more mapping with Hercules in the future. So last summer I came out and we kind of got a prototype mapping system working for Hercules. And this year we're trying to make it a little more streamlined and more of a tool that can be used on any given ROV dive. So, and really what that buys us is what we lose in the amount of territory we can cover with the ROV is we gain in terms of resolution. So, Albert, what's the cell size we've been using for these recent maps?
I think we've been gridding to 100 meter resolution, right?
Okay.
So that's like a soccer field size, saying that everything within that soccer field is like in the same height. So
yeah,
you can
it's
imagine.
Like 1 pixel.
Yeah, 1 pixel of the image
field.
is basically a soccer field.
Yeah.
And like you can imagine, like if you put a soccer field onto a slope of a mountain, you can imagine that on one end on the soccer field and the other end of the soccer field there might be like tens of meters of difference, right? So that's the resolution that we get from the ship, which is astonishing compared to altimetry resolution and definition. But like when you go to the system that you're working on,
yeah,
it's
when we're going to
insane.
the system we're working on, we will, over many hours, we'll survey the area of a couple soccer fields, but we will get a resolution of half a meter or a meter, or if we want, we can go all the way down to centimeters resolution. So, you know, so you can see something the size of like a soccer ball on the seafloor. So, but again, it comes at the cost of taking a lot of time and covering a much smaller area. So you have to find a point of interest in the large map, and then.
But that's very interesting for some little features, right? So like,
yeah, absolutely.
Geologists and biologists can geolocate precisely different things that they see, because all these maps are also like georeferenced, right? Through the Hercules positioning system. So
that's correct.
So scientists can actually like know where the things they were taking, for instance, where they were, what the shape that the environment around the sample was,
correct,
and all this very interesting information for later explanation of what that sample meant for science.
Yeah, and one of the things that we're actually hoping to do now is because we can do such a fast turnaround with these maps, we want to be able to do a map ahead of time on an ROV dive and actually use that to influence our dive. So if we're looking for certain geological features, we have a much better sort of map to help find those along the way.
And a question, how do you prioritize different targets? Like, how do you decide where to go? Like, where we're going to do the dives?
I think that is a question for whatever the lead scientist is. We do so many different things, right? So one of the big projects last year was methane seeps. So one of the ways that we did that is we actually, instead of looking at the seafloor data in the mapping, we looked at the water column data. The methane seeps release methane gas bubbles, which can be seen actually very clearly in the water column view on the on the ship's multi-beam system, and then we can further locate those with the mapping system on Hercules. We can even point the mapping system on Hercules forward, so we can look out in the distance and see bubbles flying up, and then zoom up to them and go and collect samples and do things like that. But that was just one example. It varies on every single cruise, right? If it's a biology cruise, you're looking at certain kinds of habitat, maybe rocky outcrops or things like that. If it's a geology cruise, you're looking for, bulbous magma lobates or something like whatever you're looking for, right? It's really a conversation with the science team.
Right, because sometimes it's reconnaissance, right? As in, like this trip we're doing reconnaissance for the next expedition, correct?
Sure. Yes.
Yep.
Yeah, and Taylor Ann, who's going to be on the next expedition. Taylor Ann, what are some of the sort of characteristics and maps that you're looking for to choose where you're going to dive next week or next week?
So I'm not entirely sure of exactly the points that the lead scientists will be choosing to dive on, or why they chose those spots. I have a list of those targets that we are hitting, but mostly they want to be able to characterize all of the biology that is there. So that would include, your typical seafloor creatures like corals and sponges, as well as like holothurians or like sea cucumbers and things like that. So basically, we want to be able to take transects and just kind of take note of what is there and what we're seeing, and also be taking eDNA samples to know what type of organisms could have been in that environment if they move around, and what other type of DNA they might have left behind in that environment. So there will be a good suite of samples that we'll be collecting to characterize what's there in terms of the organisms and in what density and diversity they are there.
Very exciting. And up on the screen right now is a map that shows some of those target areas that we have been mapping. This is from a couple of days ago. So some of those red stars are in greater detail at this point, but it's a good example of sort of that blanket analogy, right? That lighter blue color is what we're able to gather from satellite altimetry data. And then the more detailed green coloring is what we've collected and what previous expeditions have collected in terms of bathymetry data. So you can really see on this screen, right, these red targets are potential dive sites for the next cruise where we've come in and we've been able to really get an idea of what that feature looks like. And Haley, you all have come across some very interesting features and some big discrepancies between, what the satellite information was telling us and what our data told us, right?
Yeah, so like you said earlier, that blanket that the satellite altimetry gives us an idea that something is there usually, but not the details. And those details can be just a few meters off, or in the case that we've seen in some of the seamounts, hundreds of meters off. I think we had like a 500-meter difference on one of the seamounts, and then the ridge feature that we're currently surveying just looks like a very smooth, flat, featureless plane, but we have found that it has a lot of very interesting like collapses and slumps on it, and that we have some really fascinating geology going on this particular ridge. So yeah, this is for sure finding a lot of unique and interesting things on these new seamounts and ridges that we're mapping.
Fantastic. And if we have an ROV expert on board, I have to ask the fan favorite question. What happens if the ROV loses communication at any point or the cable breaks? Does it automatically return to the surface, or what goes on with that?
It does not.
No, it does not.
I confirmed this last year.
Yes. Wait, can you tell us the tale?
Well, everything goes black in here, and everybody gets confused for a minute, and then everybody slowly gets sad, and then we work with another ship, with another ROV, and we keep track of our location, and everybody keeps calm and goes and gets the vehicle. So Hercules does actually float, which is good, but it's attached to Argus, which very sinks.
slow descent down and up. Actually, if Taylor Ann, if you don't mind answering a question, we've got someone wondering how you become a science manager.
That's a great question. It looks like we lost connection from our, speaking of losing connections,
Oh, man.
from our scientist ashore, but we are going to ping her back in just a moment. We just have to reboot really quickly.
No problem. Actually,
yeah.
if you have the mental capacity to do that and answer a question, Maddie, I've got a question for you.
Of course, yeah. Let's do this.
Yeah, so why is public outreach so important for you, since our science communication skills seem to be excellent here?
Yeah, that is such a great question. And of course, science informs pretty much everything we do in our daily lives, whether you're a scientist or not, right? So from maybe the medication that you take on the daily to, how much you work out, to what you eat, to the weather and the clothes that you're deciding to wear based on that weather, we're using science to inform our daily life. And the best way to really describe why communicating the science is so important is the need to get people like all of our amazing Nautilus Live fans excited about what we do and exploring the ocean, because there's so much that we don't yet know about the ocean and about how the ocean influences our world systems, right? So if you're in a landlocked state, I live in Montana when I'm not on the ship, you might say, well, how the heck does the ocean even affect me there? But we're learning so much. Earlier, Chris mentioned methane seeps, for example, and those were only recently discovered in the past couple of decades, and every year we're finding more and more methane seeps. And as we're learning more about those methane seeps, we're asking questions like, how do they contribute to climate change, or to the world's climatic system? So things that we don't even know are in the ocean, and we don't even know yet how they really impact our world and our daily life. And so understanding, how the ocean informs us is kind of at the core of what we do here on EV Nautilus. And of course, it's what makes this science so important to communicate out. And on that note, we do have Taylor Ann back online. Hey, Taylor Ann, thanks for coming back. We missed you. And then, of course, in that brief disconnect, we had a question directed right to you. Adrian, would you like to repeat that for her?
Yeah, someone was just wondering how you become a science manager.
Yes, I didn't even hear that question last time. Okay, so I became a science manager through the internship program that OET offers. I did not know about this internship program until I think I finished my undergraduate degree in biology at the time. But I had already known that I wanted to at least be in the arena of marine science. So I lived in a landlocked state, just as mentioned earlier, and I didn't have any physical connection to the ocean. So I just studied general biology with the hopes that I could, get into an internship related to the ocean. And in my last year of undergrad, I was able to make that opportunity happen by connecting with EV Nautilus and interning with them in the following year in 2019. And that was a great experience, and I highly, highly recommend it for any students interested. So I didn't have any previous ocean science experience before going on that internship, but they do a great job at training you with all the skills that you need and making you feel more than capable of doing the work. So I'll be returning out for my third or fourth year now as a science manager. So just going back out every year, excited to learn, eager to get my hands messy, lose a lot of sleep, but ultimately have a lot of fun and learn a lot about science. So it's not limited to your degree being, in ocean science. I just had a general biology degree. So yeah, I think there are multiple pathways that you can become a science manager, whether that's on the Nautilus or, get into this type of research in general.
Do you mind telling us what a science manager does? Seems like a kind of a general title.
Yeah, so what I do aboard the Nautilus is I'm responsible for making sure all of the science is collected by our team for the scientists that are, have different wants or needs for scientific exploration. So we collect those samples and make sure they're collected appropriately and stored in appropriate containers on the ROV, and that we're, getting a good characterization of a place that we haven't even seen before or just want more data on. So it's my responsibility as that manager to make sure all of that biological data is being stored and given to the proper scientists that will later on analyze the samples or whatever it is that we collected for them. So, I'm responsible for taking notes on each dive, writing up reports, training interns, and the best part is dealing with the samples when they come up from the ROV, being able to handle them and prep them for further lab analysis or, museum specimens for Harvard.
And Taylor Ann, can you tell us a little bit more about what happens when we find a new organism and collect it? What does it happen to that organism after it leaves the Nautilus and goes off to another organization?
Yeah, so it depends on what the goals are for that cruise. So there could be, just goals of understanding what is there and if species are, in fact, maybe new species that we're discovering. So a lot of the samples that we get will be sent off to the Museum of Comparative Zoology at Harvard. And I have also collected my own samples for my own research as a master's student at California State University, Northridge, where I'm studying microplastic pollution in the deep sea. So samples like that actually went back to the lab with me, and I had my own lab processes to identify and see if there are microplastics being found in the deep sea, which we already know in certain places that has been true. So my research is focusing on microplastic pollution, specifically within the Monterey Bay and Channel Islands National Marine Sanctuaries, and that data was collected in 2020. So I collected water samples and some organisms that were then, placed in ethanol and taken back to the lab with me, where I further processed them and will be able to analyze that data now to write up my thesis and also share that science with the world.
So that ocean exploration is very much connected to ocean conservation then.
Very much so, yeah. I believe that my passion for the ocean, started off with exploration and then realizing if I want to explore, I also need to conserve. And not realizing that, humans have such a massive impact on the health of the ocean. So we should do our part to also take care of it. So that's kind of where my passion came from behind, my journey as a science manager on the Nautilus. So science and conservation.
Fantastic. And to those of you who are just tuning in to our live Q&A session to celebrate World Ocean Day, please feel free to leave your questions at nautiluslive.org. We are answering them live until almost 11:30 Hawaiian Standard Time. So guys, general question for everyone. What's your favorite part about being on board the exploration vessel Nautilus?
Oh, I feel like this is kind of what we did for our Instagram story today, right,
Yeah,
Adrian?
that's right.
Yeah.
So if you want to head over to our Instagram stories, we are updating throughout the day of what our favorite part of the ocean was. And I didn't put mine on because it was cheesy when I recorded it. But I like that we always are discovering something new. So we're always getting surprised by something.
Yeah, we're definitely nearly always getting surprised by something, which is what makes ocean exploration so exciting, right? Like, as we said earlier, we have better maps of Mars than we do our own seafloor, and we are on a mapping cruise here, and we're collecting mapping data. And as Haley mentioned earlier, right, there are huge discrepancies in satellite altimetry data, what we think we know about the ocean, and then when we actually collect bathymetry data from the ship, and we get to really see in finer detail what that seafloor feature looks like. Haley, what would you say your favorite thing about the ocean is? Does it have to do with mapping?
That's a great question. I mean, I am very fond of the maps. It's what we just said about the satellite altimetry and the seafloor. What we're looking at, honestly, is like we're the first eyes to really see the detail of this region. That's one of my favorite things, is I get to start from the very beginning of my research and look at the actual data as it was collected, and I was the first eyes to see this detail that I know of. And that's probably my favorite part, is like that I get to see the data for the first time and get to see the seafloor that no one's ever seen before. Yeah.
Paul, you had a really good answer to what your favorite thing about the ocean was, right?
Yes, in my particular case, before I used to sail in cargo ship or passenger ship, and I feel myself like a ship driver only. But now I working for an important thing for the world, and for me it's very exciting to see all these creatures and organisms down about 4,000 meters, where the light is, the sunlight is not reached there, and heavy pressure, and I cannot imagine how these organisms can survive, you know. I feel now that I drive a ship for an important matters for the world, and that's all.
Yeah, it's amazing.
I want to say that with the different mates that I've been working through these years in the Nautilus, they all feel this. Like, I don't know how they treat you in the other vessels or what, but I'm very glad that you are so happy. All the mates that come to the Nautilus are very glad, and they are very happy that they are working for a very neat or very good cause of understanding better our world, right? I just wanted to point out that it's not only you, but like the rest of the mates that I've been working with, they all feel the same, and it's very nice.
I could tell you that the another ships are boring, and here you get some fun, you know.
We have some fun, that's right. And it definitely, you know, it takes all different kinds of backgrounds to come aboard Nautilus and to contribute to an expedition like the one that we're currently on, from, you know, science communicators and educators to engineers, both mechanical and computer-based, mappers and biologists and geologists. So if you are interested in getting involved with EV Nautilus or exploring the deep ocean, there are plenty of opportunities. Really what we love to say is as long as you have a passion for it, you'll find a way here. And as Yashira mentioned earlier, a lot of those opportunities offered through Ocean Exploration Trust is available at nautiluslive.org. And you can just click on the education tab to learn a little bit more about fellowships and internships. And we also have a wide breadth of education resources for teachers. So if you're an educator and you want to help your students understand the mission of OET and sort of what goes into deep sea exploration, go ahead and check out that tab at nautiluslive.org and have fun with all of the many different educational resources that we have. And Yashira, you work kind of in the education field, right? What is your favorite part about being in the ocean, and how does that relate to education?
Yeah, of course. So I work as a non-formal science educator, and I'm also training in school to become an instructional designer. So that means that I'd combine learning theory, research, instructional design, and design theory to bring exciting and engaging educational experiences. And that's what we try to do here on Nautilus through these types of in-depth programs, and also through our STEAM modules. So we're not only focusing on the science, technology, engineering, and math, but we also have arts in there. And I would like to point out all of the modules are available in Spanish. If anyone that is Spanish speaking would like to bring those resources to the children in their schools or science centers. And my favorite part of being out here is actually being able to share all of this excitement with everyone at home, so we don't get to keep it for ourselves. It feels like a very unique experience, but being able to stream this live out into the world, it's definitely exciting, and I hope we're inspiring some future explorers at home right now.
Absolutely. And of course, you know, as we're all lifelong learners, that's a part of this. We're learning every single day out here at sea with the information that we gather. And then, of course, many of our interns are currently working towards educational goals in the academic sector. Ariana, what is your favorite part about the ocean as someone who is in school, and how is it informing your current research?
So currently I actually focus on harmful algal blooms mainly. So those are your microbes such as cyanobacteria or something like Carenia brevis if you're from Florida. And they can get to a certain amount where they just take over an area and they release toxins, or they just take over an area and are just harmful. So just that part of the ocean and understanding, like being from Florida, that our impacts of like pollution and nutrients affect our daily lives really does make me interested in the ocean, because it really does impact our daily lives. So that's what I find interesting about the ocean, and it impacts my research because I directly do research on it.
Right, just as we said, even if you're in a landlocked state, right, we're still impacted by global ocean systems and the research that we do out here, which includes some work by our interns. Of course, Elijah, you are an intern. You came here from a pretty unique background. You're not necessarily researching ocean science per se, but you're into an ocean club, which is sort of your leeway at to EV Nautilus. Elijah, what's your favorite part about the ocean?
So on Instagram, I know I said one thing, but I'm actually going to change my answer right here. But I think what I appreciate most about the ocean is just generally how pretty it is. Like anywhere you look, I see a scene from a movie. I could see a scene out of a movie. Just this morning, we were dropping a probe, but there was a bunch of cloud cover, which it's actually tends to be very clear out here, but there's a lot of clouds. But the sun was on the other side of the ship, but all the light basically reached around behind the clouds, and there was this beautiful red glow coming from behind, like hidden behind the clouds. And it's so pretty to just look at any time of the day.
It really is. Like right now, we just queued up a look at our aft deck, and that's in real time. So that, exactly like Elijah is saying, it is just a scene out of a movie every single day, whether it's the sunrise or the sunset. We have people on watch 24 hours a day who are seeing all the very different places in the sky that the sun likes to hang out with, and it's all equally as beautiful. Aaron, I want to toss it over to you. What is your favorite part about the ocean?
Oh my gosh. Everything. It's just so unexplored. I don't know. It's so exciting every single time I'm out here that I get to do this job, whether that's mapping or navigating, and just get to see every single time we put Hercules in and see something. It's just mind blowing. So I don't know. I don't know what else to say. It's just, it's great. Great job. Great life. Great ocean.
It really is. And Elijah, I also want to change my Instagram answer. I think my favorite part about the ocean and what we do here is the people. I know it sounds really cheesy, but we just have such a stellar crew of both science and ship crew, and we work really well together, and we're positive. And I can't say enough about all of you and the work that we do here. So thank you for contributing to this very important mission, and of course the broader objectives that OET stands for. Chris, did you tell us what your favorite part of the ocean is? I see you and Albert back there pointing at something.
Oh yeah, we were discussing mapping trajectories up there.
Nice.
We're very excited for the upcoming turn.
Ooh, me too.
So I don't know, I guess for me I feel like it's one of the last truly wild places on the planet. One of the last places that still has something to explore. So, I mean, that's kind of why I'm out here. And that's why I try to develop the tools that I develop. That I just think it's amazing to come out here and like develop something at home, work on it for a long time, and then use it to see something in a different way that nobody's ever seen before. So
You could have recorded that and put it on Instagram.
Well, for those of you that are just joining, a reminder, this is a special event for World Ocean Day. We have just a few minutes left here in the control van. We're ending promptly on the hour, or the half hour rather. So if you do have any burning questions, please do submit them at nautiluslive.org. Adrian and Yashira are behind the helm of that computer over there to field your questions and let you know a little bit more about the work. Taylor Ann, I don't recall if you answered the question of what your favorite part about the ocean is.
I don't believe that I did. Other than it being strikingly beautiful, I'd say I think it's quite astonishing how it connects all of us, no matter where we are, no matter what piece of land we're dwelling on. That it's, our primary source of transportation from, way back in the day when the first ships were created, to now. And just being out there, it's just so peaceful to just feel at one with the sea and, just take it all in. I just think that it's just so big, and it reminds me that I'm very small and that my problems are also very small.
Yep, the people at home agree that it is quite peaceful. At least it is to look at. Being on these waves rolling around, does everyone feel, do we maybe feel a little seasick?
Oh, it feels great right now.
We are rolling along. Some people are more prone to seasickness than others. I would like to put out a public service announcement that being seasick is not shameful. It does not mean that you are a bad sailor. There are people that get seasick every time they come out, and they stay seasick the entire time, and that's just part of life. So it's okay. An ROV question. So the research or exploration vessel Nautilus is a ship, so it doesn't do any diving itself, but we do send ROVs down. Do they have a maximum limit that they can be down, or can they be down for as long as we can man them on board? Chris, you're our only ROV guy here. I mean, I could answer this.
Sorry, one more time?
the ROVs, do they have a maximum limit on how long they can stay down? Or
yeah, as long as they're not broken.
As long as they're not broken.
So we've had, I don't know, like 48 hours? I think we've done 4 days or something at some point.
I've done more than 48 hours.
I've done more than 48, yeah.
I think it's 72 hours.
So, yeah, okay, yeah. So, I mean, days, they can be down. But generally, either the mission ends or we need to come up for some kind of technical reason or something.
Or because the scientists just pick up too
We're
many
often
stuff.
limited by...
Oh, that's the other thing.
full.
Yeah, the samples are full too. That also happens, yeah?
Was that an Aaron?
Yeah, I just said the same thing. We're often limited by the bio box. Once that's full, the scientists typically want to come up. So
Right.
that's another limitation. But
What about the AUVs? They're battery powered, correct?
Yeah. AUVs are battery powered, and there are different types of AUVs. There are some kind of long range AUVs that can stay in water for a very long time. Most of the AUVs would have mission times between 6 and 10 hours. But for instance, there are other unmanned submersible autonomous vehicles like gliders that they can be out at sea for months without any human controlling them, and they have tiny batteries, and they use flotation, the changing on flotation to like glide.
Explanation, of course, we do have different systems aboard Nautilus, including our AUVs, as Albert mentioned, and we will be also testing some additional technologies later this season, so be sure to head to nautiluslive.org to stay tuned with those expeditions and what exactly is going on. We're just hitting our ending mark, but I am just so happy with